So, um, so let's talk about how we are really building a pipelines in this couple of slides. I will try to explain uh, the main concepts that allows us to build a pipeline. So I will start with the pipeline basics. I will talk about processes, inputs, outputs, and script. And then I will cover the building blocks that we are using, while, file, and set. And finally, I will show you a few examples that help you to understand how this Nextflow pipeline is actually works. So let's start with the basics. Uh, let's enter one of the pipeline as an example. You can see that there are orange circles are located in the workflow. They are called input parameters. And if you drag and drop this input parameters button over the workflow, it will create these circles. So as soon as you inserted this input parameter in the workflow, it will create an input field inside the run page. So for example, bulk barcode file gonna be asked for the user in order to enter them. And other options is you can drag and drop these output parameters, and then this output circle will create an report inside this report tab in our run page. So basically we are specifying what kind of outputs we're gonna show to the user after the run completed. Let's take a look at the little bit more simple version of the pipeline. We have only one input and one output and one process. If we click this settings icon on top of it, it will show us this window where you can see the name of the process. You can see the menu group, which is the menu group that found in the left sidebar. And we have this parameters section where we can define new parameters and edit parameters that I will talk about later. And let's focus on these main three things. First of all, inputs, outputs, and the script is located in here. Since we have only one input right now, only one input circle is created, input node is created in this process. Similarly, we have only one output over here since we defined only one. And what we are actually doing is after entering all these inputs and outputs and script definitions, we are creating these, we are using this information to create a Nextflow script behind the scene. And when you execute the job, DolphinNext create this Nextflow script and submit the job inside your host environment. That could be a maybe cloud or our GHPCC cluster. This could be anywhere. So this video shows how this drag and drop interface works. So I'm gonna drag and drop this input parameter into the workflow like this. Now, if I click the edit button, I can change its name. Now, I can search the processes through this search bar and drag and drop other output parameter over here. And if I want to connect some nodes, I just need to click both of them to create an edge. It's going to look like this. I can change the output parameter name, and I can choose the how this output file is going to be visualized in our report table. And so that's basically it. Now I can drag and drop all these circles and adjust according to my needs. Okay, let's talk about our building blocks. Over here, we have three main building blocks that Nextflow uses. uh, which allows us to transfer the files and the values between these nodes. So the simplest one is a val qualifier. It simply sends string values to one another. And file qualifier is really simple. It just sends files to the next node. And set is a little bit different. It uses more than one qualifier inside of a block. So over here as an example, one val block and one file block is exist in this set block. So uh, let me show you a few examples. It's going to be much more clear. So as soon as we create this input parameters, they are working like a factory to create our building blocks. And when for example, this, when we created the pipeline like this building block is created over here. Like in this example, it's in a file format. And the reason that the block is created in a file format is behind the description of the process. Since we define this reads in a file format over here, DolphinNext knows that it needs to create a file block to supply this node. So it creates this file block and send to the FastQC process. And now FastQC execute the process and creates another file block, for example. And then we can transfer this one to another process, and it will create another block, which might be a set block. So we are specifying these blocks by using these qualifiers. So let's check our parameters section. So how we are adding a new parameter. If you click this plus button, this window will show up and it will ask us a few fields like identifier, qualifier, and the file type. Let me show you a few examples. If you choose the qualifier as val, we just need to enter some identifier. So it's just a name for that input parameter. And if you choose a qualifier file or set, we need to enter a file type as well. So let me show you one example. Why we are using this file type feature is it's related to our user interface. So when we come to one of the output node, for example, our user interface shows only the available nodes that it gonna connect. So over here, only one input node is highlighted, and the rest of the input nodes are kind of smaller, so it's not allowed to connect. So how we are highlighting these input nodes is by using these file type fields for file and set. And for the val value, we are using this identifier name. And as you can see, I can only connect these two nodes. And let's check another example. For this node, for example, this file type defined as TSV, and there is no such input node that has a TSV file type. So there are no available nodes to connect. And for the other one, we can simply connect like this. And let's check how we are really using these parameters inside this inputs block or outputs. So when we choose these blocks inside this process, you can see where the identifier looks like, and the qualifier is located over here. So over here, we need to enter some kind of a keyword, which we call it a variable. So the value that we are transferring are sent to some kind of variable, and we are using this variable inside our script. So let me show you, actually in the next slide it's going to be much more clear, but for a comparison, I'm going to go through with these file block as well. So again, I define only one variable over here, but for the set, for example, I define two different variables. So since I'm expecting one val variable and one file variable, I can define this thing like this. So let me show you one example, which will start with the val block. So over here in the input section, I will define a one val block, and DolphinNext will create this val block as a first initial step. And the user will see that this any text input in their run page, and they need to enter this some keyword inside this any text field. So when we enter this value hello world as an example, this hello world keyword gonna transfer to this process, and now we will execute our script. Since we assigned this value hello world to a variable, we can use this text inside of our script. Since we're gonna use this text as a variable, right now I'm using the bash notation, so I added this $sign as a prefix. And this command gonna be executed behind the scene. So the hello world text gonna be written inside this example.txt file. And now, since we created this example.txt, we just want to publish this file. And as an output file, I'm gonna choose this txt file format as an output. And right now over here, I need to specify the file name with a kind of a pattern. Right now, I only created one file, so I'm gonna cover with this code and specify that I just want example.txt from this process. So I will show you a little bit more examples about this output section in next slides. So since we defined this output circle, this is gonna be published in a report folder inside our report directory. And so let's check how this run logs look like. As you can see, only one job is submitted, and you can see the subdirectory over here, and the reported file is look like this. There is only one txt file, and inside there is only hello world text. So that was the simplest example that we can use. Let's work with the files right now. So I just enter a path of the FASTQ file by using the manually tab over here. And I enter the location of the one FASTQ file. So over here in input section looks a little bit different. Now I defined this block as file. And since I defined this as a file, DolphinNext will create this file block for me and transfer this control underscore rep1 FASTQ to our process. Now, this is the script that I'm going to execute. Since I assigned this read file to this variable, I can use this $read inside this script section. So you might remember this command from our first sessions. So wc -l gonna count all the lines in the file, and we're gonna use awk to divide with 4 to get a read count value. And we're gonna save this value to this count.txt. So this is the command that's going to be executed behind the scene, and we will create this count.txt file. And we just use this expression to catch this file from this process. Now let's see how it works. There's only one job submitted in the logs, and we have one file that shows all the read amount inside of this file, and it's called count.txt. And let's make this process a little bit more complicated, and let's enter multiple read files. Right now, I have entered 3 single end reads. I used the file type and created a collection and entered 3 reads. And I haven't changed this part, so it's all the same. And since I entered 3 reads, these 3 reads gonna be created and executed in the parallel. And when you check the run logs, you will see that 3 jobs submitted at the same time. And all these processes are gonna create this count.txt file. The problem is when they wanna publish these files in the same folder, they're gonna overwrite each other. So that's the thing that we don't want, and we need to find a solution. So as you can see in the run reports, only one count.txt file reported. So the solution is adding some prefix to this count.txt file. So one simple solution would be like this. Since this read keyword has a description for the read file itself, and it has a value for the control underscore wrap1.fastq. If we use over here as a prefix, all the count files gonna look like different, and they won't going to overwrite each other. So over here, I use a little bit different notation, but both things are the same thing. So when I use with another, use this variable as a prefix, I need to specify the curly brackets to specify the variable itself. So this is how it's gonna look like behind the scene, and it will create our files like this, count.txt files like this. And in order to specify all these count.txt files, I need to use some kind of a regular expression, and this star called glob pattern. And like this version, this star means that anything can match to this field, and any file that ends with count.txt gonna be exported inside this count directory. So they all gonna be exported, and as you can see, there are 3 output files, and they didn't overwrite each other. So the problem with this scenario is this control reads looking a little bit long, and we have this fastq keyword that we don't want to use actually. So we can come up with a much cleaner solution if we use the set block. So when we use the set block, actually Nextflow creates us this, it actually separates the file name for us and the file itself like this. And we can use this block file name and file read as a pattern to catch the name of the file. So it's gonna be much simpler. So we're gonna use only the name of this file. So when we execute the process, it will create these count files. So only the sample name gonna be found in the that txt file. And inside this output section, I can specify by entering dollar curly brackets name to specify those reads. So I can use these variables inside this output as well. So as you can see, it's much cleaner now. So let's change our scenario a little bit different. Now we want to support the paired reads. So not just one read, we will have this paired structure. So now I need to add one more input parameter for this scenario. So it's called mate. And when you insert this mate parameter over here and choose this mate parameter as pair, DolphinNext will create this data structure. So at first it will send this name to the process, and then the paired reads are going to be found in the next block. So we haven't changed this structure. So the name gonna be the same, and the reads will have the two reads that are paired. So it will come to this point for the execution, and it will create this name.txt file. And let's execute this one, and everything is over the same. But when we check this run reports, there are something weird is going on. We are seeing 3 lines over here. And that's interesting, since when you execute the wc-l command with the multiple files, it shows the both the count files for both of the files first, and then it shows the total amount of the file. And that's the issue actually for our scenario, since we only want the counts for only the 2 files. So how we're going to solve this issue is we can use a conditional script over here. So let's check another example. Over here, we can use this mate variable, and we can make the script conditional. So when this mate keyword is selected as pair, we will grab only the first 2 lines of the WCL command. And otherwise, it will just use the output of the command like this. So we have this if-else block inside the script section. And for the paired reads, now it's looking much more cleaner. And for single reads, again, we have a single read support. So by just changing pair mate parameter with pair and single, we can execute the same kind of a script and get the output like this. So my final example is going to be merging the tables. Right now we can create these read counts as a text file, and now we want to merge them into a single consolidated table. What we can do is different operators for this input section. So right now I choose the collect operator to uh, get together all these count txt files into a single process. So when I use this collect operator, this txt file is gonna have all the control files, all the count files inside this variable. So the script starts with some echo command, which will insert some headers for our count.tsv file. And then I'm gonna concatenate this txt files inside this count.tsv file. And this is gonna be executed behind the scene, and count.tsv gonna be created. And this is how it looks like in our report section. So we have a nice table structure in our reports. So regarding to operators, you can always check Nextflow web page. Their operators are explained over here. They have about 50 different operators that you can do different operations. And this is just a quick summary of what we have done. We just started with this val example. We just use enter a text value, which was hello world, and we publish this text in a single file. And now, then in the second scenario, we use the file block and count the reads inside of the FASTQ file and publish in this file format. And then we use set version. Now we started using both names and the file names, file itself inside the sum, inside in the same field. And we use this conditional block over here. And we supported both single and the paired reads. And finally, I show you this operators, which is called collect in this example, to create consolidated tables. And that was it. Right now, you're gonna go and try to build a pipeline by using our, let me check, session 5_2 MD file. So you're gonna go through this tutorial to create an pipeline. So we have a video summary, so how it will show how it should work.